day 2, Math 30, so Unit 1, Lesson 1, Part 2. I broke it up because I talked too much on the opening day. Okay, so Qubit Functions. So this one's basically just having you look at your calculator. Okay, so if you don't have your calculator, that's okay today. I'll start integrating Desmos more so you can see it. I like Desmos for visual. A lot of you guys put Visual Learner on your note card, which is great. Desmos is perfect for that. If you don't know what Desmos is, it's a free app you can get. You can do easy, quick graphing. It does a lot of really cool different color lines, so you can see differences in how graphs grow and whatnot. We'll definitely get into that soon. But what I'm saying is that we do need a graphing calculator, not just like you can get by with it for the school year. There's a bunch of free apps. The Desmos one's fine, but unfortunately we can't use that when? On the diploma, right? Or the test, right? So we want to make sure we get those graphing calculators if we can. If you need help getting one, or if you want to see if we can work out something where maybe the math department can buy a couple that we can, loan, we can figure something out like that. But at any rate, this is just graphing, okay? I think we're fine with graphing. The things I want to talk about with the cubics is, we kind of got to it, maybe not with your class, but so we talk about with quadratics, all x values are cool, right? Because we can plug in an x value at all times with a quadratic. Well, what about cubic? Is that the same? Yeah. There's nothing here that's restricting my x's. Like, there's nothing that says, oh, you can't put a 0 there. Okay? So let's just talk about that while I'm going at it. Okay? Okay? Why don't we think about what are things that are problems for x? What are things we can't do operations-wise in math that just end up giving us problems? Do you remember in Math 20, you had a little section on this after rational functions? Reciprocal, yep. And so where's the issues? Do you remember? He's right, though. He said that's the lesson. Reciprocal functions, there is an issue with x. So something like this, very simple. Yeah. So when you look at this, and we're going off the grid a little bit here. Okay, it's not really anything to do with cubic. 1 over x. Why is 0 a problem? We can't divide by 0. And so that gives us those asymptotes, and those are restrictions on x. So I'm saying to you, we don't have any fractions here. We don't have anything in here that's going to make us say, hey, x can't be this. So when you get to your regular cubic and quadratics, you're pretty much, like Bobber said, x, xer. We're cool with quadratics and cubic. Okay? Now, what's interesting about cubic compared to quadratic is it turns again, because we add another degree. We know parabolas are just that. Well, cubics are going to be that. It turns again. So instead of, like the parabola, see how it has that little twist here, it comes back. That's why cubics can be negative, because they go both directions. Parabolas only go one direction, right? Because you square something, it's always going to be what? Positive. Well, you cube something, it can be positive or negative, right? And so that's what causes that turn, okay? So we're just talking about the specifics of this. So let's see here. Who has their calculator? Who wants to help me out? I'll let you guys help me from your desk with this. So give me, let's just, if you have your calculators, if you have somebody who's got one next to you, let's put in this function to your calculator. Let's graph it. And if we can go ahead and help me out and give me the zeros, I'll roughly sketch it, and then we'll talk about the interval above 0. Okay, let's do that. So we're going to graph in your calculator or look on with a friend, and you're going to give me the x-intercepts. So just do the intercepts of you should have up to 3. You could have 1. But yeah, go ahead and do that, and I'll pause the video here. All right, just going around seeing some of your guys' graphs. We do have 3 intersections. It looks roughly like this. Whoops. Roughly like that. Mine's a little bit skinny compared to your guys's, but okay. Okay, give me some zeros if you will, please. So what are some zeros? We should have 3 zeros. What was that? 2, good. 0.76, so that's going to, we're going to go to 0.8. It says nearest 10. Yeah, you're right. 0.76, we'll round that to 0.8. Okay, good. And what's the next one, last one? Looks like, so this right here is 0.8. Okay, that's 0.8. This one right here, it looks like that's 2. And then what's this guy? 5.2. Okay, so now, look at that last question. How about you? I'm going to flip this to you. What is that last part C asking you to do? This This is a comprehension thing. This is exactly what the diploma is going to do to you. Well, what is it asking me to do? What does it mean? I want you to tell me. What is part C asking you to do? Yeah, Pavo? Okay, did you guys hear that? It's asking you when is y above 0. And it wants that in interval. So then you look at your graph. Now I'm going to say this in kind of a weird way. How many pieces of an interval are you going to have? You hear what I'm saying? How many pieces of an interval are you going to have? So here, watch. We'll use some technology here. Nothing special. Don't get excited. Whoops. Let's go. There we go. Okay, so this is going to be red. How come? That's below 0. And then this is going to be red. So we don't want those pieces. Okay? But we do want this piece and this piece. So what are those in interval notation? Well, the thing is, we just found these zeros, so we know what these spots are. So we know, I'll do the first piece, it's going to be between 0.8, okay, actually, let's look here. We're going to, oh, whoops, it's 5.2, right? Okay, I'll put 0.8 and comma 2. We know we want to be between there, right? Now here's my next question. Close bracket or round bracket? What do you think? Round is correct. Why? They said we can't be 0, so we can't be either. These are zeros, right? So we can't be them. When you have more than one interval, I don't know if you guys have ever seen this before, okay, to write them, they take commas sometimes, but the actually appropriate way is to put union. So it's like combining. So you can put a U. If you want to just write them, it's fine. That's more of a calculus thing, okay? It's a really awful U, sorry. That's not any better, but I'm just going to keep going. Okay, and then round brackets, it's going to be, what's the last piece? Who wants to help me out? What's the last piece? 5.2 infinity, good. So I like, guys, all of us just participating. 5 people help me with that. That's perfect. Okay, not just one person. That's good. All right. If some of you guys in your card said you're shy, that's fine. Just be following along. Okay, that's all we're going to talk about with cubic. Any questions with that? Good. All right, absolute value. What shape's an absolute value function? You should know from Math30. The V, right? They got that sharp turn. Because they're a combination of the positive, and this is what this is telling you. And I'll tell you, it's the funniest thing in Math30. For whatever reason, we just don't understand this. But absolute value is the combination of the positive and the negative graph. And the reason they have to do the negative is because it has to flip because your graph can't be negative. Let me explain this one time. We'll see if you guys like it or not. So we all know that y equals x looks like that, right? Y equals x looks like that. Yeah, go ahead. X inputs gives you y outputs. If I absolute value an input, what's my outputs have to be? Let me say that again. If I absolute value my inputs of x, what's my outputs have to be? Positive, right? Good, Kiki. Has to be positive. So when you draw this graph, the problem with this graph, go back to our color coding here, if I can. Well, we'll just do black. Okay, this is no good because those are negative y values. So what this is telling you is that for that piece, you got to flip your graph to a negative x graph. And so instead, you take this, you twist it up. This line is negative x. You see how we changed the slope? That's all it's talking about. So it's taking that, your y equals x, the whole thing doesn't work. Because down here is no good. So we flip it and we make it opposite. Just like you do with absolute value. If I put a -3 in, what are you going to tell me? It's 3. Okay? That's flipping the graph. So let's look at x minus 2. So we know that x minus 2 looks like this. Down 2 here, up 1 over 1, up 1 over 1. Draw that little simple line. So where's the issue here? How about this? Tell me the x value where the issue takes place. 2. Good. Do you guys hear that? 2. Because you can see at 2 is when we go from positive land to negative land. Okay, that's a problem. Okay? So,
Why is this a problem?
because these are all negative y values, and when we put in a number, so watch, if I put in 0, what's 0 minus 2? It's negative 2, right? But what's the absolute value of negative 2? It's supposed to be up here. So to visualize it, yeah, so visualize it in the sense that anything below your axis is a problem for the regular graph. So what I'm trying to explain to you is, see how we twist it here? We twist right here. Okay? And it's going to be, so what's the opposite of this? What's the opposite of x minus 2? This is the cool part. Negative x plus 2, right? So watch this. Negative x plus 2. Plus 2, down 1 over 1, down 1. Oh, fancy that. It makes the b. You flipped it. That's where it's at. Okay. Again, I go into more detail sometimes. Okay. So if I'm making it actually more confusing because I'm explaining more, maybe just filter it out if you can. Okay. But I do like to see. I don't want you to say, "Oh, I just flip it." I want you to know why. Okay. Oops, sorry. Any questions with that?
Can it be the other way around?
Yes. So good. What would cause the v to flip upside down? A negative outside the absolute value. Okay, so if you had a negative here, now we want negative because everything that comes out is going to be negative because this negative can't be touched by the absolute value. Yeah. Okay, very good question. Okay, so to cause a v to go upside down, guys, outside the absolute value, negative needs to be there. Okay, what causes the absolute values to stretch? Just like parabolas. You can do this. That would be a flip and a stretch, right? The negative there, and then the 2 would make your numbers stretch 2 faster. Okay, stuff like that. All right. Anything else? All right, perfect. You guys are good. All right, so let's look at radical functions. Another one section that a lot of people didn't like in Math 20. Radical functions are the radicals. Okay, now, do radicals have, so we talked about cubics, we talked about absolute value, okay, we talked about quadratics, and we said, hey, all x's are fine for those, there's no problem with x, right? How about this one? Is there problems for x? Do radicals have restrictions? Do radicals have something you're like, can't do that? Yeah.
Not equals 0.
Close. We can do square root 0. Square root 0 is 0. That's okay. But you're on the right track. What's that? Oh, sorry. Yes, by definition, it has to be a real number. But let's see. Actually, you're close. Not real number, it's whole number in the number system. Okay? But the key point is, guys, we can't square root negatives. Right? Why can't you square root a negative? Who wants to give me the explanation why? Then you're just told you can't. Correct. It is undefined. Why is it undefined, though? Do you know the why is it undefined? Exactly. You can never multiply something by itself and get to be negative. So you can't square root something that's negative because it's not possible. Okay? So you listened yesterday. It's good. All right. So now, if we know, so when we're talking about a number line, we have 0, and then we have our positives and our negatives, right? So what I'm going to tell you is when you're doing these, your breaking point is the 0 inside the radical. You're like, what do you mean? Well, think about this like if it was like I said, what's the 0 of 2x minus 1 if we said, solved it by factoring, just pretend. What's that 0? 1/2, right? Add the 1, divide the 2. It's 1/2. So that's where your restriction starts because that's the 0. Because watch, put in 0 here. So we said 1/2, right? So let's try 0. 0 is to the left, right? 2 times 0 is 0. Minus 1, whoops, -1. No good. So we start here and we go that way. So greater than equal to, right? Okay, so if I'm writing out the interval notation, it says builder, so we can do builder and interval. Okay, so we're just going to do this part first and then we'll sketch. Okay, I'll do interval because I've been doing that. And then, Cole, you want to do the builder? The inequality one? Okay. So then we have, we can do 1/2. 1/2 is good, so we're going to do a block for interval, and then it's to infinity. That's your interval, and that's domain. Excuse me, that's domain. Okay. You can just do it like inequality cosine. But the builder is just this, it's for like, you're going to go domain. It's x bar, and then it's the inequality. So how would you write that inequality? Yes. So the x still. That's all right. So we're doing 1/2 and bigger. Yep. You're right. X is greater than or equal to 1/2. There you go. Okay? That's your set builder. Okay, let's think about the range real quick. Range, we know we're dealing with y, so we can go ahead and just cheat for the set builder, put y bar, and we know we want range here. What can the y's be for this? Well, if we're doing a radical, we know when we square root we can't get a negative, so it's going to start at where? 0. 0 is the smallest we can get. Okay? So 0 is the smallest we can get. So we know for our set, again, 0 is okay, so that can be erased. So 0, box to my interval, and then that line looks like this. We'll go ahead and just do the, looks like that. So it's slowly growing what? Up. And it's not stopping. That makes sense, right? The bigger you get, the bigger square root you get. 100, 10, 225, 15, as you go. But it's going to slightly keep getting bigger. So there's no restriction on the size. Okay, who wants to take a shot at the set builder? Someone new. Or Travis, you want to try it? What's set builder for that one? Good. Y greater than or equal to 0. Okay. Clicking along. You guys are doing great. Okay, I think I'm confident you guys are fine with the function notation. What's this mean? F of 2. What's that mean? Just tells you to put 2 in for x. Just do that, please. Just do those. I'll give you guys a break here for me talking. Try those function notations, examples. You're just plugging in those values for x and giving me a value. Okay, let me see. I'm going to have some people answer here. All right, so Denise, what did you get for A? Okay, this is how it works, guys. I'm going to go 17. I'm going to put it up there. I'll kind of explain. If you didn't get that or not close and you want to see it, just raise your hand. That's all you got to do. You don't have to say I didn't get it. Just raise your hand. You don't have to say anything, okay? So it's 17. You simply put the 2 here. 2 squared plus 4 times 2 plus 5, you'll get 17. Okay? Part B. Who's my part B? Ty? 2x squared plus 8x plus 10. You simply, that means 2 times the function. You multiply everything in the function by 2. Okay? Perfect. Part 3. 2x cubed plus 8x squared plus 10x, you said? Okay, that looks good to me. You simply put 2x in here. Okay? So let's see here. Yep, that should be right. Well, let's see. Oh, wait, no. Let's look at it. There's a little bit of difference here. Yeah, you just have an extra term there, Ollie. Okay, so the difference, I see what Ollie did. So this is what he did. Completely normal. See how that says f of 2 of x? That means that goes in for x. Ollie multiplied the function by 2x. So he did this. That's what Ollie's answer is. 2x times f of x. Does that make sense? Okay, so when you actually do it this way, what's 2 squared? 4, x squared, so 4x squared, okay, plus 8x, and the 5 stays the same. Constants will stay the same, right, when you're plugging stuff in, because nothing gets plugged in with it. Okay, any questions on that one? Okay, remember, look at the difference here. 2f of x, f of 2x. All right. F of x minus 2. Who is that one? Manu, was that you? Oh, you were 5? Who was 4? Oh, you did 5? All right, I'll do 4. No big deal. Okay, this just means function minus 2. So write the function, and then just put minus 2 next to it and combine like terms. That's all you have to do. So just 5 minus 2 is all you're doing with that one. So x squared plus 4x plus 3. All right, somebody did 5. It's fine. Cassie, do you want to do this one? She got x squared plus 1. Any questions on that one? That one you do have to FOIL a bit. You want to see that one? Okay, so x squared plus 1. I'll show you the setup and I'll step aside so you can see it. So this is one where you're plugging in x minus 2 in for x. So look, x minus 2 squared, 4 times x minus 2, where their x was, and then 5 stays by itself because there's no x there. So the work you have to do a little bit, you have to FOIL this out. When you FOIL x minus 2 out, that's x squared minus 4x plus 4. And then it's plus 4x minus 8 for that. And now we have to combine like terms. So again, this FOILed out gets you here. Distribute, gets you here. 5, still 5. Okay, so if you're confused, her x's went away. Why? Negative 4x, positive 4x. They cancel. There's no more x's. There's her x squared. Okay, 4 plus 5 is 9, minus 8, 1. Okay. Anything else on that one? Okay, let's hit the last one. Just plugging in a negative x. So what this is doing is you're just pretty much testing odd even. We'll talk about that later. But you put that in there, negative. A negative x is what? So what'd you get there, Ethan? X squared minus 4x plus 5. So I want you to notice, you put negative x into the x squared. Well, that squared is still what? Positive, so you keep it x squared. Okay? 4 times negative x is now a negative 4x, and the 5 stays the same. Okay. All right. Cool. Almost done with this one here. Okay. Consider the function x cubed. Match the function on the bottom row with the expansion on the top row. Okay. So these are what we're plugging in. Where's the answer? Is what they're saying. So this is our function, x cubed. So let's do this one real quick. Let's do an easy one. F of 5. That means we do 5 cubed. So that is C. Okay, go ahead and finish those. Do the second set too. All right, so let's do, where's x plus 5 at? Number 1, which letter does it go with? B, good. Okay, and f of x. Or sorry, f of 5x. D, good. And then process of elimination, which you'll be good at the diploma, right? A. Okay, good. All right, example 9, absolute value, write the following in terms of function f. Okay, so we're trying to write it in terms of like how you would write it in terms of f of x. So function notation, so going the other way. Okay, so what is happening to this one? It's just subtracting 4. Well, my f of x, it's essentially just, that's f of x, so write f of x right there. That's all you have to do. So f of x minus 4. Right? It's just replacing it. Because absolute value of x is the f of x. Equals is. Okay? Now, a little tricky here. So we know it's going to be our function minus 2, but what's happened to our functions? What's been adjusted? So how do I write that? Yep. So f of x plus 3. Since this changed, this changes. Okay, and then minus the 2. Good. Okay, and last couple here, how about C? Perfect. And D. Good, you guys are seeing it. All right, perfect. Okay, so we still have about 40 minutes, so what I'm going to do is I'm going to give you guys 10 right now of independent just to work on this homework assignment, the practice assignment in your book. I think I plan on doing, I'm going to plan on checking Thursday to see how much you did the last 2 lessons. Okay, so we'll finish up lesson 2 today still.